Hey guys, this is Professor Janacek, and I want to go over an application of vector-valued functions. This is connected with the idea of arc length. I want to talk about trajectories. For a trajectory given by r of t, we can find both the speed and the length of that trajectory. So the speed associated with the trajectory is given by the magnitude of v of t. Now v is r prime, so we're going to take the derivative of r and then find its magnitude. That gives us the speed. And for the length, this is where the arc length idea comes in. It is simply L, which is the arc length. That's the integral from a to b of v of t dt, which is the same as the integral from a to b of r, the magnitude of r prime. So we can find the speed simply by finding the magnitude of the derivative of r, and then if we integrate that magnitude, we get the arc length. Let's try an example. So here we have the trajectory r of t is equal to the components 5 cosine t squared, 5 sine t squared, and 12 t squared. We want to find the associated speed and length when t goes from 0 to 2. Okay, so to begin with, we already have r of t. Let me just jot that down. I want to make sure you notice that for these, it's the t value that's squared, not the sine or the cosine functions, just the t value. Okay, we have that. Then we can find r prime. Let me go ahead and write it as v. Simply taught by taking the derivative of each component. Now be careful with this. We will need to use the chain rule. We'll take the derivative of cosine and then multiply that by the derivative of t squared. So let's see, the first one we end up with negative 10t cosine, oh, nope, not cosine anymore, sine t squared for the first component. The second component gives us a positive 10t cosine t squared. Again, be careful with that chain rule on those two. And the third component is simply 24t. We only need the power rule on that one. Okay, so let's find the speed. That is simply the magnitude of vector v. So that means we're going to take the square root of the sum of the squares of each component. So let's see here. I can write this a little better. Notice I'm not integrating, I'm just finding the magnitude. No integral yet, we'll get there. So let's see, we have 100t squared sine squared t squared. Notice all these things that are squared. The sine function is squared, the t in front of the sine squared is squared, and the t that's the argument of the sine squared is also squared. We have the same thing with the cosine, 100t squared cosine squared t squared. And then 24t, if we square that, 24 and 24, multiply that out. You should be able to do this without a calculator. Gives you, what's that, 576t squared? Yeah, okay. Now what we want to do next, so I'm going to go ahead and factor out that 100t squared, and notice what's left is sine squared plus cosine squared which is just a 1. So now we have the square root of 100t squared plus 576t squared. Combine those, we get the square root of 676t squared, which, again, I don't have these memorized, but I could do a little work here. And I believe that ends up being 26t. Again, please make sure that you are aware of how to do this without a calculator. Also, you'll notice I don't need to put the absolute values on t. I know that t is remaining positive because it goes from 0 to 2. All right, well, there's the speed. How about the length? Well, this is where we're going to introduce the integral. We're going to integrate from 0 to 2 of the magnitude. Well, fortunately, we just found the magnitude of dt. Oh, that's going to make life so much easier now. So we're going to integrate from 0 to 2 of 26t dt, which gives us 13t squared, which will evaluate from 0 to 2. So that's going to be 13 2 squared minus 13 times 0 squared. A little bit of a computation there, not too much. That gives us 13 and 4 is 52. Well, there you go. The speed is 26t, and the length of that trajectory is 52. Enjoy!